So now we're going to the last presentation within this fan block which we have, and it's coming from Oskar Betschmann, who is managing director for Ziehl Abegg since 2006, who has a mechanical background and who's talking about bionic concepts for increased energy efficient fan systems. So I'm really looking forward how you can combine bionics and fan design to get better efficiency. Let's hear from Oskar Betschmann.
Thank you very much for this kind introduction. My name is Oskar Betschmann, Managing Director at Ziehl Abegg in Switzerland. It's an honor and a pleasure for me to present an easy way how to increase efficiency and air performance of existing fan units. I would like to introduce company Ziehl Abegg as a global player first, connectivity IoT. Then I would like to present two successful projects which we have realized this year in Switzerland. At the end of the presentation, a short summary. Ziehl Abegg was founded 1910 in Berlin after the war was destroyed and rebuilt in Künzelsau. It's approximately 1 hour north of Stuttgart in Germany. We had a very nice growth all over the year. Today we have 29 subsidiaries, 16 production sites worldwide, 113 sales offices in 105 countries. Our philosophy is global presence and close attendance to our customer means local support, responsibility and stability additional. I don't want to point out every single point on this slide. Only two are important for me as well. Biometric systems, performance or bionic, and IoT. Ziehl Abegg has a cloud which is located in Germany. And with this cloud, we are able to analyze fans. Every EC fan in our products is able to communicate with this cloud. We have sensors, temperature sensor, vibration sensors integrated in a motor, which gives us the possibility to analyze the situation and the status of this single EC fan if the user is allowed. It means in 10 years after supplying the product, you got an email, fan 135, please replace in the next few months because the lifetime getting to the end according vibration or temperature. The word is here, proactive maintenance. On one side, the future, on the other side, reality as we live today. The next point, and this is also very important, aerodynamic. Bionic. Bionic means analysis of nature combined with technical level as we have today. 30, 40 years ago, we thought as a human being we have everything under control. The nature have to follow up what we want. Today we have realized, painful, the nature has their own rules. We have to accept, we have to follow the rules. And the nature is telling us what is efficient and what not. Two examples I have today for you. One is an owl. The owl is hunting mouse. The mouse has very good ears, but it's not possible for the mouse to hear the owl during the attack. We analyzed it, the wing, and we created 15 years ago the OLED axial impeller. This what you can see now is the 7th generation. Winglets and serrated trailing edge. Serrated trailing edge, the function is this cutting one big turbulence in very small. And the result you can see on every airport today. There's winglets to increase efficiency, and serrated tailing edge, also efficient, and especially noise, to reduce the noise. This is the axial family. Today we are talking fan units, that means normally centrifugal fans. Here we have analyzed the fin whale. The fin whale is swimming approximately 40,000 kilometers a year. It looks like a truck. It's not really efficient. It's not really aerodynamics, but it is very high efficient. And the result of this analysis are the centrifugal fan. You can see the fin we analyzed and we implemented into this centrifugal fan, but you can see the result is approximately 15% higher efficiency than every other product on the global market. So, on one side is the product, but how to use in units. Here, it's my pleasure to present two projects. One project is the University Hospital in Zurich. It was in spring this year. We had a demand to increase the air volume according to the terrible corona situation. So we realized this project, Project HOVE, it means belt-driven double inlet fan, air direction from the left to the right. The volume or duty point 34,000 cubic meter approximately on 380 Pascal static. The goals of this project were redundancy 100% given, it's a must for a hospital, reduce maintenance effort down to 0, and the energy saving at least 20%. You can see on the left hand side a bigger picture of the centrifugal fan. As I said before, direction of air from the left to the right, belt driven. So the result is here a very compact unit. Also from the left to the right. And there are 4 fans mounted in this fan combination. There are several benefits. First, we have 4 fans, not only 1. 3 fans are achieving the duty point. 1 fan is for reserve. That means if 1 fan fails, the 3 others, they're achieving the requested duty point to 100%. And in the same time, there's a possibility to reduce the power consumption. All the fans are connected by Modbus. And it's an important part is to disassemble a fan like this on the left hand side, you need a complete team to replace this fan. To replace a fan of the new system, you need only 2 workers. So it's really a massive cost reduction. The results: energy consumption of the old system approximately 86,000 kilowatt per year. Of the new system, we could realize 19,000 kilowatts per year, and it is an energy saving over 70%, which is measured. We have a ROI of 2.7 years. We have an increase of air performance of 10%, and at the same time we could reduce the power consumption. There's no maintenance needed anymore, and each single fan is connected by Modbus. And if something happens, you have the possibility to connect every single fan by a mobile phone. The next project we actually have realized in Zurich as well. There's a shopping mall Letzi Park in Zurich. It's a project called Manor, which you can see down there on the right hand side. We have here also the same situation. We have belt driven, centrifugal fan, double inlet, direction of air from the right to the left. The duty point was approximately 82,000 cubic meter on 600 Pascal static pressure. The goals here as well: redundancy 100% given, reduce maintenance effort as well down to 0, and energy saving 35 to 40% was the target. On one side, it's very simple to explain what we can do, but there's always a challenge how we could realize. We have a short movie to show how simple it is. Here you can see the 3 fans. They were disassembled of a complete team. Also, the casing has removed. At the same time, as you can see here, direction of air from the left to the right. There's a metal construction which we fixed on the ground on top, and then they have to build the plates to fix the fan, each fan on these plates. As I said, from the left to the right, complete unit is connected by Modbus, and is also a complete communication exists. Okay, this was the explanation of a very easy way how to remove old system. So come to the result of this project, ladies and gentlemen. There's an energy consumption of the old system of approximately 235,000 kilowatt a year. With the new system, we could realize only 77,000 kilowatt per year, and this was measured. This is an energy saving over 67% realized. There was a ROI of 3 years for the complete rebuild. No maintenance needed anymore. Each single fan is connected by Modbus, and analysis of every single fan is possible by mobile phone according to the first project. Well, ladies and gentlemen, why you should renew your fan units with products from Ziehl Abegg? It's not only, let me say, helpful to realize an efficient disassembling and mounting of the new product, it is necessary also to use the best efficient products. Ziehl Abegg is offering the highest level of product development in the global market. We are able to connect every single EC product with IoT or clouds. We have the highest efficiency in aerodynamics and control technology. And the next point, ladies and gentlemen, is very important. If you're sitting in US, China, Turkey, wherever on the world, if you have a project in retrofitting, in increasing of air performance efficiency, please contact our global headquarters. We have a retrofitting organization globally, and you get the support local in your individual country. At the same time, it is possible to increase the air performance and reducing CO2 output. And normally the ROI for that unit, or that kind of unit, below 4 years. So, as I said before, we offering our experience as a retrofit partner in more than 105 countries all over the world. These were only 2 examples which I presented today to you. But we have realized several projects like this. So our experience and our success is really tremendous. So ladies and gentlemen, give us a chance. Let us share our success with you. We would like to offer our support to secure your success in that kind of business. It will be our pleasure if you contact us for support at any time. Thank you very much for your attention, ladies and gentlemen, and take care of you in this crazy time. Thank you very much.
Thank you very much, Mr. Betschmann. I hope now to see you live, yes. And I was wondering if you would have a good picture and good quality, because it's probably the closest distance between Zurich and Zurich, I guess, huh?
I guess so as well, yeah.
That's very good. Thank you very much for this interesting presentation. I was wondering, I mean, the very impressive energy savings you actually propose here. The title of your presentation was the Bionics concept. So I was wondering, you know, you replace basically belt-driven old motors, large fan systems with an array of smaller, probably direct-driven systems. How much of this energy saving would you contribute to this bionic design or optimized aerodynamics of your blades, to the whole energy saving you showed?
Only the bionic, I would say at least 30%, at least. Because, I mean, what is efficiency? Efficiency is on one side the electronical part, and on the other side the aerodynamic part. And many companies, they are, let me say, replacing motors from IE1 to IE3 motors, but let me say they want to save the money, and they keep the old aerodynamics execution. Let me say they keep it on their old units. So there is a bit an increase of efficiency, but the real benefit is really the, let me say, the combination of bionic, high technology, of easy technology, and regulation.
Yep. There is actually currently one question from Roland Pierce, who was actually exactly asking this question, how the energy savings materialize between old and new systems in the project. So it's not only the fan efficiency, but it's the combination of motor and fan efficiency. And only if you improve both, you actually have this huge benefit which you showed. Huh?
Yes and no.
Yes.
I think I always say it needs a complete system. It means fans, it means motors, and regulation, controlled regulation, optimized with bus. Then I'm fully agree.
I have a question to that later on too, but there is Fernando Nuno who is actually asking, what is typically the energy efficiency level of the motors you use in your retrofit solutions? Is it still AC induction motor, IE3, IE4, or are you going to permanent magnet solutions?
EC permanent magnet solution.
EC permanent magnet solutions, huh? Yeah. And if you would make the classification according to IE, would you say it's rather IE4 or even more?
IE5.
IE5, huh? Very
with a new, well, let me say, we had, let me say, this year in the beginning, we had, or we were developing new generation of EC technology, and this new EC technology is according to IE5.
Okay, very interesting. So coming back to, you said control is an important part, or system design, I guess also, because you showed how you replace with 4 fans, and then you have a 3+1 redundancy. But coupled to that, I guess, is also your approach for Internet of Things, with total control and periodic, let's say, always monitoring of the performance and maintenance on demand. One of our audience asked actually, what about data security? How you handle the idea that the operation of fans is actually monitored, or could it be even influenced by internet, and therefore is prone to any hacking or so?
This is an absolutely sensible question, let me say. We have our own cloud in Germany, which is also secured by our IT department. The clear detail how to protect, honestly, I really have to ask our specialist in the headquarters, but this is absolutely a sensible point, which we are always, let me say, we get many questions for that point, and we really, from the sales and from the management, we really have to request this question to the specialists. But we are aware of it. Let me say like this, it's not a clear answer, but the answer
But just one thing is probably, I'm guessing you're just monitoring. You cannot remotely switch on or switch off fans. Huh? That would be much more problematic, I guess. Okay, I see that we have another question by the audience, by Ted Jones. He thinks it's a very nice presentation, also from my side. Thank you very much. And he's very interested about the motors used in this fan. So he wanted to, if you can give more details on this new EC motor design you just mentioned before.
Let me say, good question, because EC technology is actually permanent motor. So there is let me say, an AC current is to an electronic, and there is a 500 volt DC current, and this is a permanent motor inside. If you would like to get some additional information, please contact our let me say, our info mail, and it will be a pleasure to assist and to answer your question in detail about the detail of the motor.
Okay, thank you very much, Mr. Betschmann. I think we're over time now already, but that's a good thing because we have anyway a break now. So I wish you a good afternoon here in Zurich. It's rather cloudy, but I think we can enjoy now the break after your very good presentation. Thank you.
Thank you very much. My pleasure. Thank you.
Thank you very much.